James spent a lot of time in his father's workshop, watching him at work. At the age of 18, he started an apprenticeship as a precision engineer in Glasgow, which he completed in London. James learned how to manufacture scientific instruments and in doing so provided proof of his talents. In 1756, Watt returned to Glasgow. Since the length of his training did not meet the requirements of the craftsmen's guilds, he was not permitted to set up his own workshop. However, Glasgow University required his services. And in 1757, it allowed him to open up a small instrument-making business on its premises. This was a real stroke of good fortune for Watt. Since staff at the university imparted modern technical knowledge and engaged in research. Its scientists were particularly interested in the steam engine. It enabled heat to be converted into mechanical energy. In 1712, a blacksmith and inventor called Thomas Newcomen had built a practical steam engine. It was designed to improve the efficiency of water pumps in mines so that galleries could be driven further underground. With Newcomen's invention, water is made to vaporize in a boiler. The steam is fed into a cylinder. The pressure from the steam and the weight of the pump rods on the other side of the beam slowly force a piston in the cylinder upwards. The steam supply is now cut off and cold water sprayed into the cylinder. The steam condenses and its volume decreases abruptly. This creates negative pressure in the cylinder and, because of the atmospheric pressure acting from above, the piston moves back down into its original position. The water that is collected in the cylinder is drawn off and the process starts again. For many years, steam engines were used primarily for operating pumps. Newcomen's success was also revealed by the fact that a model of his machine was used at Glasgow University for explaining how steam engines worked. But the model didn't always function as well as intended. When it came to an unexpected stop yet again, it ended up on Watt's workbench for repair. James Watt began to examine a machine that was totally new to him. He discovered that the principle was not very economical, because when the cylinder fills with steam, it gets very hot, and when condensation takes place, the cylinder cools down considerably. With each working cycle, the cylinder first has to be heated up again, so a large amount of the steam supply is wasted. Is it really necessary, Watt thought, for the cylinder to cool again? Surely leaving it hot would be much more efficient, but in that case, how could the steam be condensed? Watt then had the brilliant idea of using two separate cylinders. At the start of his process, the piston is at the bottom of the cylinder. When steam is introduced under the piston, this subjects it to pressure. As with Newcomen's machine, the pressure from the steam and the weight of the pump rods force the piston upwards. Now the steam supply is cut off and a pipe leading into the second cylinder, the condenser, is opened. In this case too, the cooling of the steam creates negative pressure, which, together with the atmospheric pressure, forces the piston back down. The pipe connecting the cylinder with the condenser is then closed off again and the steam valve opened. The process can now be repeated without the steam cylinder having to cool down. In 1769, Watt had his improvements patented.